How can a computer work using only 0 and 1? A computer cannot think. It has no brain. It does not understand words, pictures, or numbers, and yet it can run games, websites, and even artificial intelligence. So how does a machine that understands nothing appear to understand everything? The answer starts with one simple idea: on and off. Inside every computer are billions of tiny electronic switches. Each switch can be on or off. We represent this using numbers. On becomes 1, off becomes 0. These numbers are called bits. One bit by itself is almost useless. It can only tell us yes or no, true or false, or on or off. But computers do not use just one bit. They use many bits together. When you group 8 bits, you get what is called a byte. A byte can represent 256 different patterns because 2 times 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 2 equals 256. Each pattern is just a different combination of zeros and ones. For example, 0100 0001 represents the letter A, 001, 10101 represents the number 5, 00, 100001 represents the symbol. The computer does not see letters, numbers, or symbols. It only sees patterns of zeros and ones. Humans decide what those patterns mean. This is how information is created inside a computer, not by understanding, but by agreement. How do computers make decisions? If computers only understand zeros and ones, how do they make decisions? Inside the computer are simple electronic circuits called logic gates. A logic gate answers very basic questions. AND gate: are both inputs on? Only then output is 1. Or gate: is at least one input on? Then output is 1. NOT gate: is the input off? Then output is the opposite. These are extremely simple rules, but when you combine millions of them, computers can perform complex tasks. For example, detecting if a player's character in a game is jumping and touching the ground at the same time, turning on the correct pixels to display a picture. This is how computers decide, not by thinking, but by following logic. The central part, CPU. Now we come to the CPU, the brain of the computer, though it does not actually think. CPU stands for Central Processing Unit. The CPU does not understand meaning. It does not make choices, it only follows instructions very, very fast. Inside the CPU, there is a repeating process. Fetch: it reads an instruction from memory. Decode: it figures out what the instruction asks for. Execute: it performs the instruction. Store/move: it stores the result and moves to the next instruction. This happens billions of times every second. Because it is so fast, it looks intelligent, but it is not. Speed creates the illusion of intelligence. Inside the CPU, there are small registers, which are temporary storage locations. There is also an ALU, arithmetic logic unit, which does all the calculations and comparisons. Even these simple parts, working together at incredible speed, allow computers to do amazing things. Memory: why computers cannot work without it. The CPU alone cannot store information. It cannot remember results or what happened before. This is why computers need memory. Memory is where data and instructions are stored temporarily. RAM, random access memory, stores information that is being actively used by the CPU. Storage, hard drive/SSD, stores information permanently, even when the computer is off. When a program runs, its instructions are placed into memory. The CPU reads these instructions, works on the data, and writes the result back. Without memory, a CPU is useless. Memory does not understand anything either. It only stores patterns of zeros and ones. Programs. Instructions for the CPU. Program is not magic. It is simply a list of instructions stored in memory. Each instruction tells the CPU exactly what to do. Add these numbers, compare these values, jump to another instruction. Nothing more, when you run a program, the CPU executes instructions one by one. If the instructions are written correctly, the result looks useful. If they are written poorly, the program fails. The computer does not know the difference. For example, a program that adds numbers can help calculate your budget. A program that draws pixels on the screen can display a photo. A program that analyzes patterns can suggest the next word in AI text generation. The computer just follows the instructions. Everything is data. When you watch a video, send a message, or play a game, remember this. The computer does not know what a video is. It does not know what a message is. It does not know what a game is. Everything is just data and instructions. Images are numbers. Sound is numbers. Text is numbers. The computer moves and transforms numbers according to instructions. That is all it ever does. Even artificial intelligence works the same way. AI does not understand what a cat is. It only detects patterns in numbers that humans have labeled cat. AI can predict text, recognize images, or recommend products, but it does not think or feel. So when people say computers are smart, they really mean computers are fast, precise, and consistent. They do exactly what we tell them to do. Nothing more, nothing less. Why this matters? Understanding how computers work with zeros and ones is the foundation of computer science. Once you understand this, everything else becomes clearer. CPU executes instructions. Memory stores data temporarily. Programs provide instructions for the CPU logic gates. Make decisions by following simple rules. Data. Everything the computer processes is ultimately numbers. All of it is built on this simple idea. On and off, zeros and ones. In the next video, we will go even deeper. We will look at how a CPU executes instructions step by step. That is where the real power of computers is revealed. Once you understand that, you will see how billions of simple actions can create amazing software, games, and even AI. It's not magic. It's logic, speed, and numbers. If you enjoyed this video and want to learn more about how computers really work, hit the like button, subscribe, and click the bell so you won't miss the next video where we explore step by step how a CPU executes instructions. And let me know in the comments, what part of computers do you find most fascinating?